come over and say, today we're doing one sample again, which is weird. We don't usually spend 2 days on one inference method. But what I want to do today is talk about how this one does not have the summary statistics version, which means that we need to find them in one variable set. And then I want to formally reteach you how to do a box plot in your calculator. So today's the day where you've got decimals for your data. Probably not a great idea to do a dot plot for that. So we do a box plot instead. Now we've been flirting with the box plot in chapter 10. And chapter 11 is kind of where it becomes, the more regular thing to do because you got a lot of decimals or averages. So that's my goal for today. Make sure that you guys know how to get your data from your calculator and get your box plot from your calculator. And what I do have to offer you is this adorable whale sticker that will make everything better. Yeah, because we care about the aquatic life in this river, although I don't really know what a blue whale would be doing in a river or stream, considering that that's like the largest, animal on the earth that we know of, but that's okay. We're just gonna ignore that minor glitch in Mrs. Talbot's plan. Right? We're ignoring? Okay. Anyway, the level of dissolved oxygen, DO, in a stream or river is important to aquatic life. There he is, aquatic. A researcher measures the DO level at 15 randomly selected locations along a stream. Then I go, oh no, I got to do a graph. Here are the results in milligrams per liter, blah, dee, blah, dee, blah. An average DO under 5 puts aquatic life at risk. Do the data, by the way, data is plural, so this is grammatically correct. We're saying data is its own plural. Just let that absorb. Provide convincing evidence at the 5% level that aquatic life is at risk. Alrighty. So the state, we need 4 things. We need the ho. We need the ha. We need some kind of context. And we need alpha. And I'm just going to put that over there to save room. Okay. This problem is talking about averages. So that means I'm in the means chapter. I'm not in the proportions chapter, trying to review for the AP exam right now. And so that means my null hypothesis is going to be mu equals something. What is the statement of no change, nothing interesting's happening, nothing's going on? Five. Yeah, but this is everything's okay, totally fine, no aquatic life at risk at all. This guy's perfectly healthy. Look at him, he's adorable. Okay, and then an average DO under 5 puts aquatic life at risk, so we're concerned that it's less than 5. Mu equals the true mean, or you could say average, I don't care, they're the same thing. What are we looking for? True mean what? Yes. In this particular stream where there lives a blue whale, which totally plausible. And right here it says a 5% significance level. That is saying alpha is 0.05. Okay, pause there. Any questions about any of that stuff? Are you sure? Are you positivo? Okay, plan. One sample t-test for mu. Random. Says randomly selected. How convenient. %. N equals 15 is less than 10% of all. Okay, what is my sample of locations along a stream? Great job. I'm sure there could be 150 locations along a stream if it's big enough to have blue whale in it. Okay. Okay, everybody good up until there. Okay, now we're gonna do the hands-on bit. So grab your calculator. We're gonna do two things while we're in the calculator. We're gonna get the stuff that we need, the summary stats that we need for this data set, and we're also going to get the box plot. We're gonna do it all at once. Okay, so put your values into L1 correctly. We'll see if I can do it at 8:45 a.m., which is feels like 7:45 a.m. Hopefully I did it. We will see. Okay, so I'm going to do two things while I'm here. I'm going to get my box plot that I need for my plan set, but I'm also going to get two things for the do step. What two things do I need from the calculator for the do step? Yep, yep. The statistic X bar and the standard deviation S sub X. So I'm going to go stat, calc, one variable stats, make sure that I have the list that I used and nothing in the frequency list. This should be blank. If you got stuff in there, that's back from chapter 6. And check mine. Did anybody get the same thing as me? Okay, we're in business then. Okay, so down here, while I'm here, I'm going to put X bar equals 4.77. And then S sub X equals 0.94. Just going to jot those down over there in my do set. Everybody good so far? Okay, so now what I'm going to do is I'm going to go, everybody watch, if you haven't done this in a while, second y equals second y equals, and this is back to chapter 1. So we're going to do our box plot in the calculator. I'm going to turn plot 1 on. So I'm going to hit enter on plot 1, and I'm going to turn plot 1 on, and I'm going to leave plot 1 on for the rest of the year because I'm going to use this so much. So you guys can turn it on and off. I'll show you how to turn it on and off so you can use the calculator for other stuff. But make sure that it's on, and then go over to the box plot with the outliers. The nice thing about your calculator is that it will do the 1.5 times IQR rule for you to show you what outliers are in your data set, which I didn't mention in chapter 1 because I wanted you to actually do it. Okay, so here is what you want. Make sure that this matches the list that you typed your stuff into, and then go zoom 9. Zoom, the number 9 is zoom stat. Oh, who was doing sine and cosine waves? Was it me? Probably. Okay, now this is the part you're like, great, that's awesome. I have a box plot on my calculator. How do I get it on my paper? Because it's on my calculator. How do I get it on my paper? And what you do is you hit the trace button, which is right next to the zoom button, and you can look at the values of the 5-number summary. And what I do is I go, okay, my lowest is 2.87. My highest is 6.38. So I'm going to start at 2.5 and go to 6.5, and I'm going to go by 0.5s on my graph paper. So your x-axis has to be consistent. So you use the trace feature to help you decide a scale. 2.53, 3.54, 4.55, 5.56, 6.5. I'm going to be looking for labels on your dot plot or box plot. I want to remind you about that for the chapter 10 test also. I'm going to be looking for a label on your x-axis. And remember, you guys, when you do paired, this is a chapter 10 thing. It's also a chapter 11 thing, but when you do paired, you want to do your dot plot of the differences. So remember, after you do the differences, then those first 2 data sets go away. You don't need them anymore. You know what I'm talking about, right? You subtract and then you use those numbers. Okay, okay, anyway. All right, so now I'm going to use the trace feature. So I have 2.87. 2.87, 4.13, 4.83, 5.5, 6.38. And this one actually looks pretty good. But does it matter? What if you get one that's skewed? Are you going to care? No. I mean, I'm saying in the FRQ land, you're not going to care. If you get an MCQ and it looks bad, and it's asking you about the conditions, you should probably care. But in these, you're not analyzing it. You're just moving on. Any questions about how to get the box plot from the calculator? And now it's on video again, so you can go back and look at this if you need to. Okay, do step. T equals statistic minus parameter over standard deviation of the statistic divided by the square root of n. Okay, remember to hit enter or use parentheses a lot when you enter this in. So I said there's a lot of people in my fifth period class that like to find this answer and then find this answer and divide them, which is totally fine. That should be 14. I have to say, in this particular problem, failing to reject is a good thing, right? Usually, I'm not excited to fail to reject, but in this case, I am excited to fail to reject. Okay. So fail to reject means you do not have convincing evidence. You have two options. You can go back up to the ha and write it in words. Or you can go back up to the question and see if you should just answer the question. And so I'm going to check that first because a lot of times that's less writing. Like just honestly, okay, do the data provide convincing evidence that aquatic life is at risk? Perfect. We do not have convincing evidence that just going to add in this stream. Doesn't mean aquatic life's not at risk everywhere. Okay, this is a really great thing to review. Type 1 and type 2 errors. Which type of error could we have made in this problem? 2. See what I did there? Did you did you see what I did? Did anybody see what I did there? I did a funny. Okay, now let me show you my kinesthetic trick for writing it in context. So since we failed to reject, we could have made a type 2 error. So type 2 error means that you failed to reject the hoe. So I'm going to cover up thing 2 because it's a type 2. So I cover up the second thing and I say to myself, okay, my sample said that the dissolved oxygen was 5. Our sample, we got a wonky sample. It led us to believe that the dissolved oxygen was 5. So I just take that and then I pick up my finger and go when it was actually less than 5. Okay, we're halfway there. You cut out your pineapple stuff, please. You have 2 pineapple things to cut out, and they're not, you should cut them apart. So, like, let me show you. The example and A go together, and then B is separate. I mean C. I mean C. I mean C. B is clear. C is clearly separate because there's no B. I'm just gonna stop talking now. I'm just making it more confusing than it was. However, I do have a pineapple sticker. Mr. Talbot got me a pineapple squishmallow for Christmas. His name is Maui, and I love him. And he's little, and he was in the top of my stocking, peeking out over the top with his little pineapple stalk at the top. What is that called? The thing at the top? No, no, no. I don't know. In my family, the tops of the strawberries are called the salad. My little, like when my kids were really little, like my son would eat the whole strawberry and my youngest would go, don't eat the salad part, you're not supposed to eat the salad. And then it just turned into like me calling them salads and now it's the salad. And now it could be the salad for you too. You know, this amazing student right here, do you guys see the awesome thing that she just did? Did anybody see it? The super awesome, cool thing she just did? She put her recycling bits in the container and not in the little basket for me to pick up later. Do you see how cool that was? See how nice that was? How she like walked her extra pieces to the recycling and didn't like dump them in the baskets for me to pick out and clean up. Yeah, let's see. Oh, look at this face. I know. And it's not even like freshman. I could understand it if it was freshman, but no, no, because I see the little 11.1B like left on the piece of paper. So I know it's from stats and I'm like, cool. You might notice that they've been cleaned out. That's because I cleaned them out last week in a fit of rage. Rage cleaning. Okay, now this one is not a full state plan, do you conclude? It is not. It's different. So it starts out the same though. At a pineapple farm, the mean weight of pineapples harvested from one large field was 31 ounces last year. A new irrigation system was installed after the harvest, and managers want to know if the mean weight has changed. Okay, so changed. That word implies what? Not equal to. Nice. Okay. They randomly select 50 adorable pineapples to weigh in the new crop. State hypotheses and define the parameter of interest. Okay, so mu equals something. And what is the current state of things? What's the current average? And we want to know if it's not 31 anymore. The true mean weight of pineapples. From this large field of pineapples. I think we should take a field trip to a pineapple field in Hawaii. We should just go to Hawaii. We could weigh pineapples and then eat them. Yeah, exactly. New irrigation system, old irrigation system, deliciousness level. Pineapple is my favorite fruit. Anyway, okay, check the conditions for performing a test. I think there are probably 3 of those just from my previous experience. Random, randomly selected. What's wrong, honey? Well, it didn't say to. I noticed down here that it said significance level of 0.05, so I just ignored it up here. I mean, if you're doing it yourself, you should, but it gave me, this is kind of a different type of problem you'll see in a moment. Randomly selected, 10%, 50. They didn't say pineapples from this field, but I sort of feel like that's implied in the question. Never been happier about CLT applying? That's not true. On the 2 sample ones. Because if it's not a difference, like a mu-d problem, you have to do both dot plots if they want, if both of them are, yeah. Okay. None of that was very interesting. That's all how it's supposed to go. Okay, now I've thrown you a curveball on purpose. But I really want to make sure that this doesn't feel like a crazy curveball. Have I not told you since January that hypothesis tests and confidence intervals are really the same thing? I really want you to know that they're the same thing. It's just the method that you choose to display your results. And I've told you a lot of times that confidence intervals are right, right? They do the same thing for you, but then they give you an added piece of information, which is a plausible range of values. So the do step in this case is a confidence interval instead, but they gave it to you. And the whole point is to use it to draw the conclusion. So a 95% confidence interval for the mean weight of this year's pineapples is 31.225 to 32.616. Based on this interval, what conclusion would you make for our hypothesis test with a significance level of 0.05? That's a question mark there. Nice job, Mr. Talbot. Screwed up your punctuation. But before we do the problem, this is an easy answer, extremely easy answer. However, I want to touch on something real quick. Does it make sense that if you have a 95% confidence interval that your alpha level would be 0.05? Okay, only if it's two-sided though. I made sure to cover myself by making it two-sided in the beginning. And if you need to review that situation, that would be back here, back here, here, here in the notes from 9.2a, where we talked about the difference between the alpha level, one-sided, two-sided, and what confidence level that meant that you had. So just want to make a note that alpha level of 0.05 on a two-sided test means that you have to split that into two pieces, which is where you get the 95%. If you need to refer back to that at any point, please do. Does it matter for this? No. Again, I am reviewing for the AP test again because I'm a forward thinker. Anyway, based on this interval, what conclusion would you make for a hypothesis test? Okay, so we're asking if mu is equal to 31 or not. Is 31 in my interval? No. Okay. Okay. So what? 31 is not a plausible value. So let me help you. But what? So you're weighing your pineapples, you're excited because they're bigger than 31. What does that mean? Yeah, you're doing a very good job of analyzing. I was just gonna say the mean weight increased. I'm gonna actually either one of those. Cameron went extra step in her conclusion. It's great. Okay, last question. I have a question just like this on the Chapter 11 test. Can we conclude that the new irrigation system caused a change in the mean weight of this year's pineapples? No, why not? I'm gonna bring this out. I was looking for this. Hold on. Okay. Random sampling allows you to generalize your results to the population, but not establish causation. Random assignment allows you to establish cause and effect. Which one was this? This one was random sampling. Okay, but why not though? I want to ask like literally what else could have happened? Just gonna say there's a confounding variable maybe of the weather. It might have just been a very particular rainy season. It might have been a very particularly sunny season. It might have been the bees were increased. Those are my only options. What else? But other than bees and weather? Fertilizer? They might have they might have done something else. I don't know. You just can't say that it's just the irrigation system. Okay. I have a joke. It is great. Converting. I don't need you to convert anything. There's no conversion necessary. Oh, I hit the wrong. Oh, they put a new button there. Oh, that's what happens over the weekend. Enjoy my joke. Do you know what video that's from? Yeah, yeah.
If you're right, oh, no, I didn't.
I like your jokes, and they were both very funny. Thank you.
Well.
Do it. Okay, now I need you guys to look at something. It's I was just this is